Okay, so you take a look at this thing, and it says standard, normal, cumulative probabilities here, okay? And so first, let's just start off with this first page, okay? So this week, we are going to work with something called the normal distribution, and then later on, the binomial distribution, okay? And so what the normal distribution looks like, it looks like a hill, okay? And this is known as the normal distribution, or sometimes we call it the bell curve. But this is what it looks like. Okay, and there are a few things to keep in mind. This is what we call, so this is the normal distribution. And this shape is known as a probability distribution. Okay. Okay, if we shade everything underneath the hill, okay, everything shaded equals 100% or 1.0. So if we shade everything, let me see, if we shade everything under the quote hill, the total area shaded is exactly 1, okay, or 100%. So far, so good? Okay, so here's just a quick check of our understanding. Oops. All right, so if I cut right there, and if I shade that, how much have I shaded? Okay, so the shaded area here is equal to what? As a decimal, shaded area here is 0.5. Okay, and the way this normal distribution works is that here it's placed on a number line, okay? So we put the normal distribution on a number line. Okay, number line is 2 words. And that means numbers in the middle, they correspond to the highest point on the hill. That means numbers in the middle are most common, okay? So values in the middle, this is where the peak of the hill is. Are most common. Values out here and out here are very rare, okay? So values far away from the middle are rare. Okay, so technically normal distributions, they can be located anywhere on the number line. So if this value in the middle could be 70, and then we could go out to 71, 72, 73, 74, 75, 76, etc. and so on and so forth. So normal distribution can be located anywhere, but if we move the normal distribution so it's centered at 0, and I'll draw one, then we call it a standard normal distribution. So I'm going to just flip to the next slide. Did everyone get this down? You don't have to worry about all the tick marks on this graph here. Okay. Okay, so here, let me just draw another normal curve. Okay. So can be located anywhere on the number line. Okay. And it can have technically any width or any spread. Okay. But if we center it at 0 and it has a standard deviation of 1, then it is called standard normal. Or Z distribution. Okay? And so what you have, the table that you have is called the Z table. This is the standard normal table. All right. So what number goes right here in the middle? 0, right? So it's centered at 0. So that means everything to the right is positive values and everything to the left is what? Negative values, okay? So, and the way we use the table, okay, is that if we look up the number 0 in the table, 0.00, what the table will tell us is the area that is shaded to the left. It says if you draw a vertical line at 0.00 and you shade everything to the left, the amount you have shaded is, how much will we have shaded? So amount shaded to the left of 0.0 is what? Left of 0.0 is 0.5, right? So the amount shaded to the left of 0 is 0.5, okay? Or, huh?
Can you show that?
Yeah, I'll show that in a moment, but I just want, okay, I just want to make sure everybody understands this concept, that the amount shaded to the left of 0 is 0.5, okay? And symbolically, we might write the probability that Z is less than 0 is equal to 0.5. Is this okay?
Yeah.
Don't look at the table yet.
Okay.
I'm just asking conceptually, does this make sense that the amount shaded to the left of 0, so our hill is centered at 0, how much is shaded? The amount shaded is 0.5, okay? And I can also write this as a probability statement saying that the probability that Z, meaning the amount shaded to the left, okay, Z less than 0, meaning we're going to the left of 0, is equal to 0.5. Is that okay? All right, so if we want to confirm this on our Z table, we can do this. We have to find the location where Z is 0.00, okay? So we can go to the positive side. This 0 actually shows up on both sides of the table. But if we go to the positive side of the table and we go to the very top left corner, we see at 0.0 and 0.00, we have 0.5. Okay? And that's because the table always lists out to 2 decimals of precision for z. Okay, so 0, if we had to carry it out to 2 decimals, is 0.00. Okay, so z equal to 0 is the same as 0.00. And what the table says, so if we go to the table, we go to the row 0.0 and the column 0.00. Because if we add these together, we get 0.00, right? So just want to make sure we're okay here. Yes? No? No. Okay, who's not okay? All right, so we're okay. Are we okay with the fact that the number 0 can also be equivalently expressed as 0.00? Okay, like you can keep sticking on zeros after the decimal point and it doesn't affect the number, right? Okay, so we're going to look up this number 0.00. Okay, 0.00 is equivalent to 0.0 plus 0.00. Is that okay? Is that throwing anybody off? I'm just doing 0 plus 0 is 0. That's all I'm saying here. Okay, but we're doing it with decimal points. We're all okay with our decimals, right? So we got 0.0 and the column 0.00. Okay, and when I look up those two numbers, I get 0.5000. Does everyone see this in the table? Okay, and that means, what that means is that the area shaded to the left of 0.00 is 0.5, or the area shaded to the left of 0 is 0.5. Is that okay? All right, so let's say I go just a little bit further, okay? Further to the right, and I go over here. And so now I'm not shading at 0.0, but I'm going to maybe 0.23. Okay? So how much do I have? Okay. How much is shaded to the left of 0.23? Okay. Well, I know you got it, but I'm going to just write the question out here. How much is shaded to the left of 0.23? Okay, so when I go to the table, what row am I going to go to? Okay, I go to the row 0.2, and which column? And I go to the column 0.03 because 0.2 plus 0.03 is 0.23. Okay? All right, and so how much is shaded to the left of 0.23? 0.5910. Is that okay? All right, so then okay, then let's just make sure our reasoning is okay. All right, have I lost anybody here?
Yes.
Yes. Okay. What? So.
Look at the row and the column for stuff.
Okay, hang on. Everybody be quiet. I have a student asking a question. I want to answer this.
So the last step, where you're locating the numbers, I can see row.
So.
I'm on the second page, right?
Yes, I'm looking at how much is shaded to the left of 0.23. 0.23. So I want to go to the row 0.2 and the column 0.03. Okay, so on my Z table, I go to the row 0.2. Is that okay? And then I go to the column 0.03, and I go to where those two numbers intersect. And that number here is 0.5910. Is that okay? And so, coming here, the area shaded to the left of 0.23 is 0.5910, and that's everything in this green area is 0.5910. and that makes sense, right? Because at 0 I had 50% shaded, or 0.5 shaded, and I'm going a little bit over to the right, so it makes sense that I would shade a little bit more. And so now I have about 59% shaded. Is that okay?
That was confused. I wasn't sure. I was looking for actually for point 23, but I see now that the row and the column.
So yeah, because if we only listed out things as they are, then we would have a massive list to have. Okay. So what they did is, you know, first look up the row 0.2 and the column 0.03. Okay. So you know. You can find all these numbers this way. Okay. Is that okay? All right. So maybe just a quick check of our understanding. If I shade this sliver red, how much is shaded red? So don't shout it out, but just think of your answer. You don't have to look this up on the table. Okay. Just reason here and say, how much did I have shaded when I have shaded to the left of 0.23? Okay, and how much is going to be in between here and here? Okay, so how much is shaded in red? What do you guys think?
We say now?
0.091, right? Because, right, so visually, how much was shaded to the left of 0.23? 0.5910, right? Area shaded to the left of 0.23, so that would be the green and the red combined, was 0.5910. Is that okay with everybody? We just went over this, right? Okay, now that's the green and the red area combined is 0.5910. This is green and red together. Okay. How much is the green? 0.5, right? We established that back here. So that means how much is in the red? If the green plus the red add up to 0.5910, and the green is 0.5, then how much has to be in the red? 0.0910. Okay? So this part is 0.0910. Is that okay? And I got this by doing 0.5910 minus 0.5 to get 0.0910. Okay. Is that okay with everybody? All right, so let's try another question here. Okay. All right. If I shade over here to the right, if I shade over here, how much is shaded in purple? Okay. So what do we know about the hill? If we shade everything under the hill, how much will we have shaded? 1, right? Okay. Do I know how much is not purple? How much is not purple? Right? We know that the red and the green combined is 0.5910. Okay? So how much has to be purple? Okay, so the purple area has to be 1 minus 0.5910. Okay, and so the purple is going to be 0.409. You can punch this in your new calculator. 1 minus 0.5910 is 0.409. I'm gonna just leave this up here, and I want to make sure visually we can see this. If the whole area under the curve is 1, the amount in purple is going to be 0.409. We have a question.
Is the red the z-score?
No, the red is not the z-score. The z-score is a location along along the axis here. So if it says if I draw a line at 0.23. Okay. All right, let's try another question here. All right. Is this okay? All right, so I'm going to just try another one here. So I've got, okay. So what number goes here in the middle? 0, okay? All right, here I'm going to try drawing a line, vertical line, at negative 1.04, okay? And I want to know okay. So we know everything adds up to 1, okay? So I'm going to ask you 2 questions. How much is shaded in blue? And how much is shaded in purple? Or magenta? Okay, so here my cutoff line is at negative 1.04. Okay, how much is shaded in blue? The answer is 0.1492, right? I go to the row, negative 1.0, and I go to the column, 0.04, okay? So I have to go to the negative side of the table, and I go to the row negative 1, and I go to the column for 0.04, and I find 0.1492. Is that okay? Okay, so I go to the row negative 1 and the column 0.04, and I get 0.1492. So that's this area over here. This area is 0.1492. So how much is purple? Yeah, so everything has to add up to 1, so I'm going to subtract 0.1492 from 1, and I get 0.8508, right? Okay, so I'm going to do something very important here, and I'm going to change these questions from how much is shaded in blue and how much is shaded in purple into questions related to probability, okay? So this question, how much is shaded in blue, can be rewritten as, okay, what is the probability that Z is less than negative 1.04, okay? I'm going to write a few versions that these are all equivalent to. What is the probability, or what percent of data have z-scores lower than negative 1.04. Okay, so these questions are asking the same thing over here, okay? Because here we just drew a line at negative 1.04 and we asked how much is shaded in blue, okay? Which is the area to the left. Okay, are these okay? We can do the same thing for the other questions. And this would be, what is the probability that Z is greater than negative 1.04? Okay. Or it could also be, what percent of data have z-scores higher than negative 1.04? Okay. Or symbolically, we can just write probability that z is greater than negative 1.04. And equivalently, over here we would write probability that z is less than negative 1.04, okay? And whether I put a less than or equal or less, these are all identical. So these are all identical answers. All of these will give me all the same. So I'll let you guys write all of that down. A z? Where? Here? Z, this is greater than or equal to. And this is less than, and this is less than or equal to. So these questions down here are all equivalent. These questions up here are all equivalent. Is this okay? Are we ready to flip to the next slide? 1 minute. Okay. Okay, here I go. Okay, so I'm going to put up some questions, a few drills here, and let's see if you can answer these questions, okay? And so these will not be accompanied by pictures, but I'll ask, what is the probability? What happened to my brush here? Okay. What is the probability that z is greater than Okay, so try these ones out. It might be helpful to draw your own picture. And so I'll give you guys a couple minutes to work on these. All right, let's draw a picture. Okay, so I hope your picture matches mine. Okay. So here's a hill. In the middle of the hill, we put 0. I'm drawing this line. I'm drawing a number of 0.6. 0.6 goes over here. And I draw a vertical line. Okay? And I'm asking, what is the probability that z is greater than 0.6? So the area that I want is over here. So far, so good, right? Okay. So we look up z equal to 0.60 in the table, and we find 0.7257. Okay? So let's think for a second, right? So 0.7257, is that more or less than a half? More than a half, right? And so 0.7257, the area and the table always gives us the area to the left, okay? Table always gives us the area to the left. So if you look up 0.6, it will give you the area to the left of 0.6, which is 0.7257, which makes sense because the area to the left of 0.6 looks like it's more than half of the hill. Okay? So how much is going to be over here? How do I get this purple area? How do I get the shaded area? I have to subtract 0.7257 from 1. So I do this, and then I get 0.2743. Is this okay with everybody?
Yeah.
And anybody still upset? Yes, I'll happily do all of these, okay? All right, so again, all of these things, let's start off by drawing a little picture here, okay? So we draw a picture. Okay. All right. In the middle, I put 0. And I'm going to 2.08. So 2.08 is to the right of 0. And I'm going to shade everything to the left. So this time I'll use blue. Okay. All right, so I look up, how do I find 2.08 in the table? What row do I go to? So z is 2.08. So I go to the row 2.0 and the column 0.08. Is that okay? So I go to 2.08, the row 2.0, and the column 0.08. And I get 0.9812. Okay, so the table says 0.9812. Does that seem like it could be the answer here? When we look at how much we've shaded? Yes, okay. We've shaded over half of the hill. So it makes sense that what we have shaded will be 0.9812. And that's our answer. Okay? The table always gives us the area to the left of the number we look up.
I don't understand why you're not doing 1 minus.
Because I'm asking, what's the probability that z is less than 2.08? Okay? So less than 2.08 means I'm shading to the left of 2.08, right? Is that okay?
It'll hit me later.
Okay. Well, no, I'm just here. I don't want to. It'll come to you later. 2.08. Okay, it's a number line. Okay. The values to the right of 2.8, are they larger or smaller than 2.08?
They're larger.
They're larger. The values to the left of 2.8, they are smaller. I'm asking, z is less than 2.8. So do I go to the right or to the left? To the left. Okay. So I'm shading to the left. Okay. The table always gives us the area to the left. So when I look up 2.08 in the table, it's going to give me the area to the left of 2.08. Is that the area that I want? And the answer is yes. Because according to my picture, and this is why it's important to draw a picture. According to my picture, listen up you guys. According to my picture, I want the area to the left. The table gives me the area to the left, so the number I get in the table is the number I want. Okay, lastly, let's do this last one. I've got z is equal to negative 1.23. So I put 0 in the middle. Where is negative 1.23? It's to the left, right? Left of 0, right? So I get negative 1.23 here. And then what do we have here? We got z greater than negative 1.23. So greater than negative 1.23, do I go to the right or to the left? I go to the right, okay? So I'm shading to the right, which means, so before we go on, when I look up a number in the table, is that the number I want?
No.
The table gives me the area to the left. What I want is the area to the right.
Oh, I see.
So I'm going to find the number in the table, and then I'm going to subtract that number from 1. So I look up negative 1.23. So I go to the row negative 1.2 and the column 0.03. And what do I get? I get 0.1093. Okay? So the area to the left is equal to 0.1093. Okay? Again, the table always gives me the area to the left, which is not the answer I want. I want the area to the right. So I do 1 minus 0.1093, and that answer is 0.8907. Question?
I've noticed if you look up positive 1.23, it gives you the answer.
That is correct. Okay, so there is a shortcut because the thing is symmetric. Okay, the area to the right of z is equivalent to the area to the left of negative z. Okay, so you can use that. If you can keep track of the signs on the left and the right in your head, you can use that as a shortcut. If you use this method, you will always get the right thing. If you can do things in your head with the shortcut, that's fine. That's what I do. That's how I got these answers so quickly. I just looked up the left and the right and the negative and the positive version. Okay? But when you're starting out, I recommend going through the step-by-step process so you don't get mixed up. But some of you have naturally visual learning systems, and you can keep track that the area to the left is the same as the area to the right of the negative version of that thing. Okay? And if you can do that, go for it. Okay? But I'm not going to try to explain it here because it ends up just confusing some students who don't have that visual learning system. Okay? But yeah, that's completely correct. Okay, we'll take a break here. We'll say 10 minutes, and then and we'll come back and we'll apply these to actual problems here.